All right, guys. Hello and welcome back. And look what I got on the board. I got another Midway 8080 game. This one is Seawolf. So we're going to be looking at a Seawolf today. This has a 2-ROM hack. So, yeah, I'll have to find out what's going on there. This looks like it was at Eldorado Games. So I don't know if they repaired it or if they sent it back. They couldn't get to it. I'm not exactly sure. Yep, but yeah, this is the is this the soundboard? This just looks like Game Logic. Does this have another board? Because this looks like it should have more discrete circuitry on it for sound. This looks like it might just all be Game Logic. I'll have to look into that. I'll have to look at the manual for this and see if this has a separate soundboard, because this thing's half empty. This looks like just the Game Logic. I know these ILD74s are used for inputs. I know that. Yikes. Yuck. Yeah, who knows? I'm going to have to look into this a little bit. This looks like it doesn't have enough circuitry to generate the sounds. So, yeah. Okay. I mean, I know this is a simplistic game, but there should be some more sound circuitry than this, I would think. So this is the early Midway style, the Space Invaders, 78 and earlier. It only has one chip here. The Space Invaders Deluxe and later have 2 chips right here. And the later ones also use those cheaper green connectors here. You'll see this connector is great. No need to replace this. I'll just clean the contacts. Those are way better quality than those green pieces of crap that they used in the later ones. This looks like it needs to be cleaned and retinned. It's just kind of a mess. So that needs to be retinned. This has copper showing, so that will be cleaned and retinned. Yeah, just some basic stuff. We'll go ahead and clean and retin all of these connectors. So yeah, I guess the first thing I want to do is find out does this thing have a soundboard? Because I did not get a soundboard with this, so I will look into that. But other than that, I need to look into the ROMs. This has I did actually take a peek at the MAME ROM file, and MAME one set is 8 ROMs, 512 byte ROMs, and then there's another set that has the 2 kilobyte ROMs. Or no, they're 1 kilobyte. That's right. The other set is 1K ROMs, 4 of them. So the total, it's a total for 4K ROM. It's a 4K ROM program. Yeah, because that would be 1, 2, 3, 4, or 1, 2, 3, 4, or 2, 4. Or you could do 1 ROM, a 2732. You could do the whole thing in 1 ROM. But we're not going to do that. You got these ROMs here. I'm going to verify that now this is a hack. This was not in MAME. That's why you see all this. So I am going to have to verify that that is done correctly, that will work. I have to dump these ROM files and make sure that they're organized in the ROM right and all that good stuff, so yeah. So I will do that. I got to make sure that that is done correctly. And if it's not done correctly, I will probably, instead of redoing those, I'll probably do it all in one ROM, just a 2732. Yeah, so, okay. Excellent. Well, let's get to it. Let's see what we got to do. And first thing I'm going to do is I got to check the program, make sure this program's right. This is a pretty cool chip right here. That's a Texas Instruments 8080, which needs to be, that socket needs to be replaced. That socket needs to be replaced, and the ROM sockets need to be replaced. Just the two that I'm going to use. And this chip needs to be cleaned. So we got some maintenance stuff to do. And make sure this strapping does not look right off the bat. This should be jumped right here, which looks like it was cut, but that needs to be jumped. I'm going to go through that, make sure the strapping's all right. This 2716, you should not need all this hackery for that. You should be able to just, I don't know, I'm going to have to look at it. I don't want to speak before I really think about what I'm talking about, so. Yep, got a little research to do, a little cleanup to do, a little maintenance to do, and then we'll see where we're at. Okay, as opposed to the last board that I worked on, the Space Encounters, this board is a lot more primitive. The ROM scheme is a lot more primitive. It's a lot more antiquated than the one that I did. This one has no ability to hook up an address bit 11 unless you run it, unless you jump it. Address bit 10 is here, but the ROM selecting is a lot different than it is on the later version board. So I get all of this hackery now. These red wires, you have to do that in order to do this. So my guess is it's probably good. So I will put the fluke on it and make sure, and I have to actually go on my computer and put these ROMs together. Like this is going to be the first 4, and this is going to be the last 4. And when I say first 4, I mean this one, this one, this one, and this one. And then this ROM is going to be this one, this one, this one, and this one combined. So, yeah. Or in the other version, that's 4 1K ROMs. This will be the first 2K, and this will be the second 2K. Yeah. So I just have to put that file together and then get a signature on it with the little signature program for Fluke. And then I'll be able to verify that those are being read correctly. But like I said before, first things first, sockets have to be replaced. And I just kind of been looking over the board, and man, there's some bad work on this thing. There's some super hackery, and I'll have to clean all that up. So we'll get it. And it looks like these sockets have been replaced. So these have been replaced as well. So what I'm going to do is just clean up the flux and clean up the work, and then I'll go ahead and clean this junk up too. Look at that. Clean all this prior work up, and then we'll hook this thing up to the fluke and see if we're reading our ROMs and RAMs. Yeah, see, this work is really terrible here. Look at that. So I'm going to have to make sure that's all good. Now I just brushed all of the solder off of this, and this is completely oxidized out and just looks like crap. So I'm gonna clean that down to copper, and then I'm going to re-tin it with my tin solder. Okay, we did our tinning and kind of cleaned up this board. Nice shiny tin solder. And then I just kind of scrubbed and cleaned this area. That's going to have to be looked at. That work's going to have to be revisited. But this had some solder blobbed up on it. This was just a mess. This needed to be cleaned up before it was put back in. Before it was put back in there. So, got it. We got that good. So we'll go ahead, and it's nice and flat now and tinned. So we can go ahead and hook up to it now. I can safely put this in the main board without worrying about wrecking the main board's edge connector. So that's what it's all about. And getting a good connection. So, okay. Well, this is very promising. RAM seems to be just fine. Still have to get signatures on these ROMs and see if they're the way they should be. So I'm going to do that next. I got to go into the computer and put these files together, grab a signature on them, and then come out and see if the signature works. Be right back. Alright, got that chip replaced. And we are now reading EPROMs. So let's do the second one, which is 800 to FFF. And that signature should be, it should be 2510. So let's do 2510. And we're good. So now we are good on this board. We're reading our ROMs, we're reading the RAMs. So I need to figure out what the pinout of this is, and I got to hook to the reset and all that. And I still want to look and see, this thing has to have a soundboard separate. So I need to look into that. And but I mean, this is good. We're good on this board now. So yeah. This is, I resoldered both of these, cleaned up all the work too. I resoldered some pins on this. Some of these, I mean, there were multiple pins where there was no solder in them, because this is so oxidized that solder does not stick well, but you have to use a good flux. So like on replacing this, I use an actual paste flux. And you have to just let the iron sit on there until it goes down into the hole, you know, into the through hole. So it's tough to solder to these. It takes twice as long to solder to a board like this, but you can do it. You just have to know how to. You have to use a good flux. You have to use a little extra time. You know, you don't want to do it on, you know, that's a socket doesn't matter. You know, you put some heat on a socket, it doesn't matter. You don't want to You don't want to have like parts that you're overheating, you know, or whatever too much, but you got to have it soldered, right? So anyway, that's good. We're good here now. And yeah, so I'm going to do some little research on this thing and find out the where to hook the reset signal at up here, and what about sounds, because I don't have another board here for this, so we may not be able to test any sounds. But I need to be able to see the gameplay. See, if I do run UUT, it's not going to work because there's no reset signal. So, all right. Let me do that. Let me find out where to hook my reset pin, and I'll be back. All right, and we are going to clean this chip. See how these legs? Somebody took something to this. You can tell that somebody took some sandpaper or something to this. Do not ever use sandpaper on legs like this. These are silver plated. All these Texas Instruments chips, back in the day, Texas Instruments used silver plating on their chips, on their logic ICs and everything. Fujitsu did a lot too. And Fujitsu, I believe, is the company that actually made a lot of Midway's custom chips. So you'll see the Fujitsu F on a lot of the Midway customs for like Galaga and that kind of thing. And they always get tarnished like this. Don't scrub these legs because they're fragile, they're brittle. Go to your hardware store and get this Tarnex. This stuff is like magic. Just take and pour some in here. Just enough to kind of cover the chip. And this will take about 10 minutes, if that. Just kind of agitate it around a little bit. And we'll come back in a handful of minutes and I'll show you the result. Okay, I would say it has literally been 2 minutes. 3 tops. These things are like new. So we'll go ahead and get this chip out of here. You don't want to over soak this. You don't want to let it sit in there way too long. Just enough to clean it off. And it just absolutely removes that stuff. So now I'm going to go in the house. I'm going to rinse this good with water. And then I'll come out and I'll dry it with the air compressor. And I take this and put this right back in the jar, in the bottle. I'll pour that right back into the bottle. But yep, this needs to now be rinsed and dried, and it'll be ready to put back in the board. And voila, as you can see, this Texas Instruments 8080 looks like new. Now I have no idea if this chip works, but we're going to find out. Let's put that back in the board and see what we got. Okay, we are hooked back up, and this is the reset. The older Midway boards take the reset right on the main board. So I have that. And then a lot of the older, or the later ones, including Space Invaders, comes up through here. But a lot of these older ones, it goes right up onto the main board. So I have reset from the main board right there. So that's where it's hooked up. And we are running. And the graphics look good. Ship looks good. Seawolf. And this does have a separate sound generator board. So we cannot do anything with sounds. Yeah, so interesting. Yeah, I really don't know if anything's, I mean, the logic part looks good because everything looks good. I'll try to coin this thing up and play through it a couple of times. I'm not going to really be able to, I don't think. We'll see. Okay, I am looking at the circuitry that does the explosion lights and all that kind of good stuff on this backboard. And I'm using my logic probe. I'm using whatchamacallit here, the meter here. I got this part of the schematic printed off. That's actually not it. It's right here. This one right here. And you got some flip-flops that are clocked. And what they're doing is these data bits are going into these flip-flops. And basically, if something explodes, there's going to be the data that will convey that to these two chips here. And these are both clocked by F4 pin 2, which is a 42. And yeah, so this thing is just should be just a running clock, like like a train, so that this thing can be sampled to sample these data bits and send them over to activate these transistors and these bulbs to light up when there's an explosion. And what I'm seeing on F4 pin 2 is there's not much going on. Let me go ahead and restart the game. So now we'll push the button and we are playing. It's playing right now. This is that 42. And you can see it's just kind of... This should be sampling, because the game is running right now. Every now and again you get pulses. But this should be like, it should be noisy. It should sound like this, basically. I would imagine you should be seeing something like this. But instead we get this. We got all kinds of inputs on this. But these two chips right here are not being sampled. And those are for the explosions. So, yeah. And then you've got more bulbs coming through, like F4 pin 3, which is busy, I think. We're going to start the game. No, it's playing. That is high. And it clocks every now and again. This 42 gets good inputs. Right now, this thing it was disabled. Okay, now it's disabled. The most significant bit is high. Not that it's disabled, it's just selecting 2 bits outside of its range, I think. It's a decade decoder. It's a 0 through 9 decoder. Yeah, I don't know. I don't think that thing's working right. That's my suspicion. So I'm going to analyze that thing. I'm going to hook up to it and analyze it. And because I was sitting here, poking around and firing my missiles and whatever. And when I'd shoot something, I would expect these to toggle. I would expect these 175 output bits to toggle to turn on those transistors, to turn on the lights. And I wasn't seeing anything. So then I went back to this 42 and I was like, okay, this thing isn't really doing anything. So I'm going to hook up the analyzer to that and just verify what I'm thinking is going on. So let's go ahead and do that. Okay, and this 42 actually tested fine, which is strange, but I say it's strange because it seems like it should be sampling those a lot more. But this board has other issues. Like right here, this chip right here, with this big nasty solder ball on this leg, there's no continuity here. If I go here, yeah, and then you just follow this trace right to this leg and there's nothing. That's an input to this. This is a 175. That's an input, and this is the outputs. The outputs are inverse, but there's nothing there. There's no input. So I'm going to have to stop, remove this stuff, and really scrutinize this work that was done. Well, I have removed those two 175s, and this was terrible. Broken ground. There was no ground. There's that broken trace that had the big solder ball on that leg. You can see it's broken. Broken trace. Power trace is broken. There's a missing pad broken trace. Pin 3. Yeah. And then the back side is even worse. Lots of breaks. So we'll go ahead and get that all repaired up, and we'll be back. Okay, and I just spent some time meticulously going through these two chips right here. Had to do a ton of trace repair. As you saw, you know, it's ugly, but it works. It is ugly, but everything's connected. And then when I was doing my beeping out, I noticed that this one was not connected, so I had to put a little jumper. But yeah, now it's all connected. So yep, we'll get ready to put this thing back together and give it a test. Okay, I got the board set put back together, and it's looking a lot better. If you noticed before, or you can rewind the video and go back, and you'll see that this ship did not look this smooth. It was kind of herky-jerky along that water. It was like, now it's smooth like it should be. So that is nice. We have fixed that. Cool. It's looking good. Yeah. You know what happened is I could have swore that those were 175s, both of them, that I fixed. I put two 175s in the thing, and all of a sudden it wouldn't work. So I put the fluke back on it, and I was getting a RAM error. And it looked like this bit right here. So I pulled that RAM, tested it, tested good. I had a 175 in where a 174 was supposed to be, and it was corrupting the data line. It was corrupting the whole data, data bus, and it was reading, the fluke was reading it as a RAM error. Yeah, weird. I just put that RAM back in the board that I pulled. It tested fine. Yeah. So I discovered that I had, a 174, or I had a 175 in the board where this one right here. I had a 175 right here. And this thing would not run with a 175 in right here. It was corrupting the whole works. I really don't see... I mean, the pinout, yeah, the pinout's different. So this thing actually had outputs hooked up to the data lines, and it was messing the data lines up. So I heard someone scratching at the door. It's cold out there, huh? It's a regular winter wonderland here. Pretty freaking cold out, huh? Boo Boo. What do you say, Boo? She's like, man, it is cold out. Alright. Coolness, though. We're looking good over here. Yeah, it took me just a minute. Thankfully didn't waste too much time on that 174 in the board. Or that 175 in place of the 174. It didn't take me long to figure that one out, so... that was nice. But yeah, this thing's looking good now.